identify different sizes of pipe. Hydrodair is imperial size, so we're talking about inches. We have a 2-inch pipe, 1.5 inch, 1 inch, 3/4 inch, 1/2 inch. They're all Hydrodair pipes, which tend to be sized in imperial measurements. This blue pipe here is MDPE, medium density polyethylene, and its measurement it's 32 millimeters, so it's a metric size. That's something you have to be conscious of with all sorts of plumbing fittings. English fittings will come in imperial sizes, continental fittings will come in metric sizes, and obviously the connections to join them can be problematic. Now, as regards a farm water system, in my view, anything less than 1 inch isn't good enough. So you're talking from 1 inch upwards for reasonably large herds of dairy cows to get sufficient water, and a 2-inch pipe is the largest that's generally used in farm settings. Now, this is all connected to the flow rate. If you double the size of pipe, you quadruple the flow rate. So a 1/2 inch pipe, the flow rate is very limited, and to double the flow rate, you have to double to quadruple the flow rate. You have to double the pipe size. So the difference in flow rate between a 1/2 inch and a 2-inch is 16 times. The difference in flow rate between a 1/2 inch and 1 inch is 4 times. So just to reiterate, anything less than 1 inch really isn't sufficient at farm level at this point in time. So you're talking about maybe 1.25 inch, 1.5 inch, 2 inch for the larger herd sizes. Modern day fittings are much easier to use than fittings of 20 or 30 years ago. What I have in my hand are a 3/4 inch inline connector. So all you have to do is dismantle on one side, and put on the fitting over the pipe, put it in and screw back together again. Now, when fittings are new, it's possible just to open them, take out the pipe, and it's a push fit to get them back together again. In other times, you had to bring a kettle of water and you had to put in the top of the pipe in order to soften it so as to get the fitting on. But modern day fittings are much easier to work with. And this is a pipe spanner used to unlock the fitting. Next, we have to cut some pipe. There are various possibilities. You could use a hacksaw. It will do it for you, but there is potential danger, and also you don't get a square end. You could use a hammer and chisel if you were really adventurous, but by far the best method of cutting pipe is with a pipe cutter. So we'll just cut a little bit of pipe. So very simple to do, not dangerous, and we end up with a nice even square edge. Okay, so the pipe cutter by far the best way of cutting pipe. And next to disassemble and reassemble the ball cock. This is your standard 1/2 inch ball cock. The float valve and the lever arm. Lever arms come in different lengths depending on the size of the trough. here we have a high pressure jet, which is standard when you buy a ball cock. Now, the problem with a high pressure jet is that it restricts the flow, and when you buy a ball cock you should probably purchase €1 a medium pressure jet. The low pressure jet leaks too easily, so that's a low pressure jet, medium pressure jet and a high pressure jet. And when you buy a ball cock, it's almost certainly going to be the high pressure jet, which is the side in it, which is a restriction on your flow rate. So you'll never get enough water for a large number of hours out of these high pressure jets, and in my view they should be replaced with the medium pressure jet. So this is the ball cock reassembled, and important that it's assembled properly, and you know that by looking in here, and you'll see the black washer cutting off the flow to the jet. This is a ball cock with a low pressure jet inside in it. Okay, so to check to see if it's assembled properly, you have to look in here and see that the flow is being cut off. Those are 1/2-inch ball cocks. This is a 3/4 inch ball cock with a low pressure jet inside in it, and it has a longer lever arm as well. All ball cocks present a flow restriction, because as the tank is filling up, what's happening is that the flow rate is reducing, so there's a restriction on the flow rate. And on modern water systems, what you tend to have are full flow valves, and what that means is that as long as the tank is filling, the full amount of water is coming out all the time. So ball cocks introduce a restriction on flow rate. The full flow valve is designed to allow much greater flow rates, and there's no restriction, because they're called full flow valves because they keep flowing out at full steam ahead until there's the shut off. Now here we have some standard fittings that you'll find inside in a co-op store. You have your T-piece to bring the water from the ground upwards. This is your 1/4 inch on-off valve, so it allows you to open and shut the flow to individual troughs. These are just connectors. This is a 3/4 inch connector. This is one for a bigger water system. It's a 40 mil, so that's approximately 1.5 inch pipe. It does the same thing, but just with bigger water pipe. This is your 90-degree connector to get you into the ball cock, and this is the same thing but with a much bigger pipe being connected. And this is the finished unit, the 3-piece to bring you up from the ground, and this is all 3/4 inch, your on-off valve, and finally your 90-degree connector, which is connected to the ball cock. So we have our ball cock, 90-degree connector, a on-off valve, which may or may not be placed in it. It's a matter of choice. And then you have the T-piece, which brings you from the ground upwards. So this is the finished scenario. Ball cock setup. In my hand we have various fittings that are needed to bring you from the ground up to the ball cock. We have the three-way fitting down here at the bottom, and I have done this up with 3/4 inch pipe for demonstration purposes. So we have our three-way fitting. We have our on-off valve, which is not necessarily mandatory in the plumbing setup here, but it's useful to be able to turn off and on the water to a particular water trough. And up here we have the 90-degree connector, which goes onto the ball cock itself. So this is the unit to bring water from ground level up to the ball cock. So just put this on now. This is our finished setup. We have the water coming in, and we have our three-way connector to take water off from the main pipe and allow it to run on to the next water trough. And we have our on-off valve here, which is probably best placed on the inside so that animals don't get at it. We have our 90-degree connector leading on to the ball cock. So that's our fitting to get from the ground up into the ball cock. So we're in one of the college dairy paddocks. The college has approximately 420 cows. So the water system that's required for a herd of that size is substantial. The trough in front of me is 300 gallons, and the rule of thumb that you use is that you need a gallon per cow. So this is a 300 gallon trough, and there are approximately 400 cows. It's a concrete trough, it's a bottom fill, and the pipeline system leading to it